The examiner had 30,000 hours in his logbooks, 16 years at the same flight school, in the same training fleet, in the same airplane. He had done this stall 1,000 times. Pull back, feel the buffet, push through, recover. On that afternoon in Illinois, he pulled back. The airplane entered a spin. He pushed forward. Nothing happened. Witnesses on the ground watched it rotate 5 turns, then 6, nose locked toward the earth. Both occupants were killed. No mechanical failure was found. The Piper Tomahawk was the trainer American aviation trusted. More than 2,400 of them left the Piper factory between 1978 and 1982, and flight schools put student pilots in their seats by the tens of thousands. The FAA had certified the design, but the airplane that arrived in those flight schools was not the airplane the FAA had certified. The production wing was structurally different from the certified prototype. It was never retested, and its own engineers warned the design would make stall behavior impossible to predict. At least 147 pilots died in crashes tied to this aircraft. We are going through the NTSB investigation files, the airworthiness directives, and the testimony of 3 Piper test pilots who told the federal government exactly what they knew. The question is not whether the FAA missed this. What the data shows is what the agency chose to do after it could no longer claim that it had. The wing is the story. The Tomahawk uses the NASA GAW-1 airfoil, the General Aviation Whitcomb profile, developed in the early 1970s as a high-lift design for the next generation of light aircraft. On paper, it was a compelling engineering choice. The GAW-1 generates more lift than a conventional wing at the same chord length, which means a shorter, lighter span for equivalent performance. The T-tail that went with it was fashionable in the mid-1970s and gave the Tomahawk a modern, fighter-like silhouette that appealed to the instructors Piper had surveyed. But the airfoil comes with a constraint. The brochure did not carry. Its designers stated plainly that the GAW-1 required a rigid structural foundation because the profile is exceptionally sensitive to shape. Small distortions in the skin change the pressure distribution across the surface. Those pressure changes alter when and how the wing stalls, and they change the direction the nose drops when it does. Piper's own engineers recorded this constraint before production began. One engineer wrote that using a flexible version of this airfoil would make it a new and unknown commodity in stalls and spins. After the FAA certified. The Tomahawk, on a single pre-production prototype built at Piper's Vero Beach facility, production moved to Lock Haven, Pennsylvania. There, without FAA involvement and without returning the changes to the certification process, the wing was modified. Full-depth ribs were reduced in number. Lightning holes were cut into the main spar. The spar itself was thinned. The structure became softer and more flexible than anything that had been in front of a government test pilot. The effect is called oil canning. Under aerodynamic load, flexible skin distorts, it buckles slightly along the chord, shifting the actual wing shape away from the profile that was certified. On a conventional airfoil, oil canning is a minor anomaly that costs some efficiency. On a GAW-1, it is a direct input into the stall sequence. The distortion changes when lift breaks down. It changes the direction of the initial wing drop, and because the degree of flex varies from airframe to airframe, depending on rivet condition, fatigue accumulation, and repair history, it produces a different response in each aircraft, no 2 stalls exactly alike. This is why Piper's own production test pilots gave investigators the testimony they did. One described the stall behavior as unpredictable, saying that across every PA-38 he flew, he never knew which direction the aircraft would roll at the stall or how far. A second said the airplanes were very unpredictable in a stall. These were not students discovering a maneuver for the first time. These were the people Piper paid to evaluate each production aircraft before it left the factory. The stall strips. Piper began installing in 1979 4 metal tabs on the inboard leading edge were designed to force airflow separation to begin at a defined location, regularizing the stall onset. The strips reduced the rate of roll at the brake. The wing drop remained. Sweden tested the modified aircraft after a 1979 fatal accident. Australia tested it independently after theirs. Both concluded that neither the original 2-strip configuration nor the 4-strip modification met FAA Part 23 wings level stall requirements. The FAA reached the opposite conclusion. The first fatal stall and spin accident in a Piper Tomahawk happened in 1978, the same year deliveries began. Sweden lost a pilot. Australia lost a pilot. Both countries investigated, and both concluded the aircraft did not comply with the American certification standard it was built to meet. Both submitted formal findings. The FAA read them and left the fleet in service. In 1979, after a fatal spin accident in Romeo, Michigan, an NTSB investigator submitted a formal recommendation to conduct an aerodynamic and certification review of the Tomahawk. The recommendation went to the NTSB's own Office of Safety Recommendations. They denied it. Let that sit. Sweden and Australia had submitted findings. Piper's own post-production test pilots had reported stall behavior as unpredictable from the day deliveries began. The regulatory system received all of it, opened a gate, and the gate said no. 6 Tomahawks had crashed fatally in the 6 months before that denial. Piper's chief engineering test pilot, William Kelly, was watching the accident reports arrive. At some point after deliveries began, he went to the company's chief legal counsel with a recommendation: buy back every Tomahawk already delivered and destroy them. Not ground them, destroy them. His reasoning was economic. He believed the handling characteristics would generate product liability claims that would cost more than the fleet recovery. Piper declined. Kelly later told NTSB investigators that he himself had entered an inadvertent flat spin in a rented Tomahawk with his son in the right seat. He recovered. Not every pilot behind him in that entry point did. By 1981, the chief of flight tests for the FAA's Eastern region had written an internal memo to the agency's engineering and manufacturing branch. 3 fatal Tomahawk spin accidents had occurred in the previous 60 days, and the memo formally requested a certification review. The review did not happen. That same year, Flight Safety International, one of the largest professional pilot training organizations in the world, evaluated the early production Tomahawk as a primary trainer and found it unsatisfactory due to unfavorable stall and spin characteristics. In 1983, 5 years after first deliveries, the FAA issued Airworthiness Directive 83-1408. It required all existing Tomahawks to be retrofitted with the 4-stall strip kit Piper had been quietly installing on new production aircraft since 1979. The FAA cited the need to standardize and improve stall characteristics. It was a mandate for hardware the agency had never tested. The FAA later confirmed this in writing. The letter said that Piper conducted stall spin tests at their Lock Haven facility. However, only Piper pilots participated, and the FAA was not involved in those tests. That letter was dated 13 years after the directive it described. On March 4, 1994, a Piper Tomahawk took off from a small airport near Inman, Kansas. The flight instructor in the left seat had 7,945 total hours, including 745 hours in the PA-38. The private pilot in the right seat was undergoing a biennial flight review. At altitude during the maneuvers portion of the review, the aircraft entered a spin. Witnesses described a left rotation of 5 to 6 turns, the nose fixed on its descending axis, rotation steady through each turn. The aircraft hit the ground. Both occupants were killed. Post-accident examination found no mechanical problems, no discrepancies, full compliance with every Piper specification. The NTSB opened what became a 300-page investigation. Lead investigator Frank Gattolin worked through design history, certification files, production engineering orders, and accident reports reaching back to the aircraft's introduction. What the investigation assembled was not an isolated accident. The pattern stretched 16 years, student pilots, flight instructors, biennial review applicants, and designated check airmen, all in the same rotation, the same descent, the same absence of mechanical cores. The NTSB also found something in the certification record that had been sitting unexamined. Piper's original certification flight test report, FT-1118, documented the spin testing performed on the pre-production prototype. The report showed that only a subset of the required stall configurations had been tested, turning flight stalls with flaps retracted, nothing more. Turning stalls with flaps extended had not been performed. Accelerated stalls in any configuration had not been performed. The FAA had granted a type certificate based on incomplete testing, then watched a modified production version of the certified design fly for 16 years before anyone examined the original test records. In January 1997, the team interviewed a third former Piper test pilot, a man who had held the title of chief pilot at Lock Haven and served simultaneously as the FAA's own delegation option authority and designated engineering representative during production. He told investigators that the Lock Haven production aircraft were nothing like the articles certified by the FAA as far as stall characteristics are concerned. He said the Piper test pilots performing post-production checks were shocked at the stall characteristics observed. He stated that the 4 stall strips had not corrected the defects he had documented at the time. Those observations had been submitted when they were made. They had not reached anyone with authority to act. In 1996, while the investigation was still underway, a FAA inspector with more than 13,500 total flight hours went up in a Tomahawk to conduct a flight instructor proficiency check. He held credentials as both an aerobatics instructor and a competition aerobatics judge. He had spun more than 15 different aircraft types. During the check, the aircraft entered a flat spin. He applied full recovery inputs, full opposite rudder, full forward elevator, and throttle to idle. The aircraft kept rotating. He unbuckled his seatbelt. He pressed his weight fully forward against the instrument panel and instructed the student to do the same. The shift in center of gravity was measured in inches. After several more rotations, the nose dropped. Recovery came at less than 1,000 feet above the ground. He landed, inspected the aircraft, and found full compliance with every published specification. A FAA inspector with 13,500 hours had to unbuckle and redistribute the weight of 2 human bodies to exit a spin in a certified, airworthy, fully compliant general aviation trainer. The agency's response, when the NTSB delivered 5 recommendations in July 1997, including the demand for expanded production spin testing under Federal Aviation Regulations Section 23.221, was to contact Piper and ask the company to search its own documentation files for evidence of FAA involvement in production testing. Production. Piper's search returned nothing. The NTSB computed the Tomahawk's fatal stall and spin accident rate for the period from 1985 to 1994. Using FAA annual flight hour survey data to establish exposure, the board placed the PA-38 at 0.336 to 0.751 fatal stall and spin accidents per 100,000 flight hours. The Cessna 150 and 152 came in at 0.098 to 0.134. Tomahawk. At the lower bound of both ranges, the Tomahawk's fatal spin rate was 3.4 times higher. At the upper bound, the gap widened to 5.6 times. For every pilot who died in a Cessna stall and spin during that decade, 5.5 died in a Tomahawk, in a fleet that was a fraction of the size. That is what an untested production wing leaves in the accident record over time. The FAA's March 1998 response to the 5 NTSB recommendations did not involve flying an airplane. They reviewed production engineering drawings against the certification-era drawings on file. The paper comparison found no discrepancy. The FAA closed its investigation. Paper. The NTSB classified the agency's response to the spin testing recommendation as open, unacceptable response. That language is precise. Open means the underlying safety issue has not been resolved. Unacceptable means the agency's stated action did not constitute a sufficient response to the board's recommendation. Aviation Safety magazine noted in 2002 that Australia, in the 1950s, had conducted fleet-wide physical spin rechecks on every de Havilland chipmunk in the country, after a single accident raised questions about spin behavior in that type. One accident. Every airframe physically spun. The Tomahawk had accumulated decades of fatal spin accidents, testimony from 3 of its manufacturer's test pilots, a documented structural gap between the certified prototype and the production aircraft, a near-fatal flat spin involving one of the FAA's own inspectors, footage of a flattening spin captured by NASA, and a fatal stall and spin rate more than 5 times that of its class. The FAA compared drawings and called the matter closed. The Tomahawk remained certificated. No production aircraft was ever physically spun by the FAA as part of a post-certification safety review. With every passing year, fewer Tomahawks appear on the FAA registry. Roughly 649 remained on the registry at last count. Time is doing what regulation chose not to. The fleet is retiring by attrition, annuals not completed, airframes turned over to parts, logbooks going into storage alongside aircraft that stopped flying years ago. The accountability that never came is being replaced, slowly, by arithmetic. What this story teaches the mechanic is not specifically about the Tomahawk. Every aircraft type has a certification event, a moment when a prototype was placed in front of government engineers and declared airworthy. What happened between that moment and the aircraft currently sitting on your ramp is a production history. The certificate does not describe. Parts were changed, drawings were revised, service bulletins were complied with, or filed and forgotten. The certificate says the type was approved. It says nothing about the specific aircraft in its current configuration, or whether the production decisions made after certification produced an airplane consistent with the original approval basis. The gap between those two things is where pilots have died. Piper's own chief test pilot knew exactly what the certification paperwork was worth when the production line started changing the wing. He recommended destroying the fleet. The agency that certified it reviewed the drawings and called the matter closed. You are the one sitting in the airplane. Which aircraft in your hangar are you trusting on the strength of a certificate and nothing else?